So I will talk about basically the GSS IAM we use in Google GCP. Actually, it's being developed right now, but it's trying to resolve this multi-tenancy problem in a single instance in the Google Cloud environment. And so the first, I will talk about why we cannot use node map and traditional GSS security, and then talk about internally and some core feature of this GSS IAM, and finally about how do we configure that. Yeah, so in the cloud environment, it's basically the security protection is based on identity, not on network location. So basically, when you want to access a resource, you need to request an IAM token, right, from the external authentication server. Then use that token to send to the server, and do the authentication. Then get authorized. Then you can access the resource. And also, they require basically you need to do this all the time. So every request needs to be authorized. And then also in this resource control, it has to be flexible. It's basically defined. You cannot define this rule for every user. Yep. And ideally, you need to define it for every directory in the directory level. And then why the other GS security flavor doesn't fit? It's because first is all the GSS kerbers is actually add extra header inside each RPC. So it's basically add extra load, especially on the client side. CPU cycle, all the network data, especially if you enable the encryption or some other signing, it probably will impact your workload. And on the other hand, the kerbers actually only verify who you are, nothing else. It's basically you prove that your identity. It doesn't verify the resource or the subdirectory, anything. And on the other hand, the other standard GSS is basically none. There's no protection. Basically, it cannot use. If you want security protection, what? Oh, okay. So node map is perfect. It works fine. But if you're using node map, it actually requires that the client has to have the group affiliation information. Basically, the client needs to prove yourself you belong to one kind of group, either by your need or by your SSH key, something. So basically, the client has to have the group information, but this is it's not feasible in the cloud environment. In the cloud environment, usually, if you have IAM server, basically, you want to access a resource. You send the request to the IAM server. IAM server only tell you that yes and no. It doesn't tell you anything else. So with this information, you cannot, send to the Lustre server to locate the node map. So basically, you cannot use that. Our solution is use this GSS IAM. So we basically, send the request to the IAM server. IAM server will authenticate your resource. Whether you can access the resource, then give you a user principal or something. Then you use this principal to create a dynamic node map. Then use the existing node map to do this whole security. I will explain that in the following page. So okay, so what's GSS IAM? It's basically a new security flavor. It's trying to, as I already said, trying to resolve this multi-tenancy issue with a single file system in the cloud environment. And it's basically a hybrid RPC mode. So you authorize the authorized phase. It's basically you use this GSS layer to set up this authentication authorization process. Once this process finishes, then everything else will go back to this non-security. Basically, it's the same as a standard RPC. So it will, make your mount process maybe a little bit slow, but the data process, once the connection is established, then yeah, everything will be the same as non-security. And this is the GSN, the handshake process. So the client is the detail process. The first step is the client. Basically, he will get a token from the external IAM server. Send a request, gets a token. Then during this mount process, he gets a token through the app call, the user app call from the kernel to the user space. Once he gets the token, he will send the mount directory and the token to the MDS. The MDS will authenticate the token with the subdirectory to the external server again. If you get authorized, it will reply you. The MDS know that this mount request get authorized. He will create a security context. In the same time, also create a dynamic node map. And then he will reply to the client with this security handle. It's a 64-bit handle. And then client use this handle to the connect to the MDS again. The MDS will locate the security context, then normal connection, create export, then attach the node map to the export. Then basically the same process as the current export with node map process. And then with GSS IAM, the mount process, a little bit different, but it's also the same. So the client goes to the MGS, gets the config log. He will check that if this connection is defined as IAM, if it's defined IAM, it goes to this process. I already explained that. Go to the external IAM server, gets token, and set up the secure connection with MDT0. Next step is after he set up, the client will connect to other servers. Then the other server, he doesn't need to talk to the external server again. He just talk to the MDT0 with existing connection, and then he gets the security context from MDT0. Got back again. He will set up this basically the same security connection. Yeah. This is mount process. And with this, since this one big purpose of this mount IAM, this is GSS IAM, is trying to isolate the mount directory totally in this multi-tenancy environment. So since the node map already has this group IDs, the squash, all the features, so we just reuse that. Basically, when you the group ID will naturally inherit it to all the subdirectories files and also even in the OST object. So what we did is that during the mount process, all the other target will get the project ID from the mount directory. Then the project ID will be attached to the node map. So the project ID is in the node map already. Then when the client wants to access any data object on OST or the MDS subdirectory, the project ID in the RPC will be replaced by the project ID attached inside the node map. So it will make sure that any RPC will not be outside, will not access the files outside of your tenancy. Yeah, basically, and also for this, IAM policy, because you might change the IAM policy at any time, and sometimes in this cloud environment, you cannot remount the file system. So basically, when you change the IAM policy, the customer doesn't want to be interrupted. So for this case, we basically will start background process. Basically, we actually changed the app call cache, but that's too detailed. So basically, we start a heartbeat background process. He will, talk to the external IAM server to refresh this policy, every 30 minutes. After he get back, he will update the IAM the node map, those permission stuff, update that, then all other servers, all other MDS, OSS will talk to the MDS 0 to refresh those permission, the IAM policy change. Same time, so so for this model, so only MDT 0 will talk to the external IAM server. Yeah. So, okay, final is just some how to use this IAM thing. So on the client side, it's pretty simple. So you need to set up the app call. The app call is for, retrieve this IAM token from external server, your external IAM server. And also for the mount process, you need to provide your user principal, because you need this mount process in the kernel go back to the user space. You need use this user principal to get the token. Yeah. So on the server side, it's also simple. You need set up your server security as the IAM flavor, security flavor, and then you need to enable the node map because it's based on the the node map framework. Node map needs to be enabled. And also, you need to set up this server-side app call for the MDS to do the authorization, to the external IAM server. Yeah, this is the server side. Yeah, so all the patch is tracking in this ticket. And also, there's HLD there, and yeah, welcome. And also, we are hoping to land this to 2.18. Yeah, that's the last one. Sorry, this is a short presentation. Oh, perfect.
I have two questions.
Yeah.
The first one, so say I gave a IAM user access to a particular set of resources on Lustre, and then Lustre will mount, it'll do the IAM kind of back and forth, and then all the subsequent RPCs are not interacting with the IAM service.
Yeah.
And then I go into the console and I revoke permissions from that IAM user.
Yeah.
Somehow I imagine that client server is interrupted. How does that mechanism work?
So so this policy change will not take effect immediately because the server side, he cannot always contact the IAM server. So he's just every 10 minutes or 20 minutes it's configurable. He will refresh his policy to the external IAM server. Once it's being refreshed, he will update this node map. There's node map permission. He update that, and after that, every following RPC, when he come, he will always check with node map.
Why not do a down call from the identity service to maybe
the
not
down
evict
call
the
is
client
that because the external IAM server doesn't have any group affiliation information, so he doesn't know which IAM I should call. For example, if for this project or for the group you change, but you have no information like which user, in this group, it doesn't. He only external you yes and no for certain resource. So you have no information to do the down call.
I think that makes sense. The other question I had was, a lot of this is very Google Cloud specific. I imagine people that run Lustre on-prem might want to use some of these features in some way. Do you know any open source, I guess, IAM provider that people could look at, maybe integrating with in the future?
I don't know. I only know Google IAM server. but it's like the external interface is through the app call. If you want to use that, then you just implement your own app call. Talk to your own, IAM server.
Makes sense.
Would the if a client gets evicted, would it need to refresh its token every time it gets?
Yes. But once the secure connection is established, the client will not, trying to reconnect. It's only reconnect when the disconnection happens, right? When the disconnection happens, he will still, if he still use the old token, talk to the server, so authorize, he found out that the token is expired. He will reply or deny. And the client will, request a new token to reestablish this connection.
Yeah, and maybe I might not have full number. So at times only few servers evict a specific client, not all the servers, right?
Yeah.
But, so in this case, MDT0 is the one which is refreshing.
Yeah.
So if other servers, not the
yes,
MDT0.
But this secure connection is per peer. It's not, so if for example, if you have disconnected with MDT1, you will use the token to talk to MDT1. MDT1 gets the token. He actually doesn't talk to the external server. He will talk to MDT0, use the token. Then MDT0 somehow will talk to the external.
I was just going to follow up on the previous question. A lot of the reason why this looks the way it does is because some of the impedance mismatch between the way Cloud IAM works and the way other things work. I would actually be surprised if much of this was applicable to other systems because they don't have the same limitations. I mean, if that turns out to not be true and this is useful, that's cool. But I think it's really unlikely.
In this MDT0 model, what if MDT0 is down or facing network issue? What would happen?
So you mean MDT0 is down?
Yeah.
Oh, but I mean, MDT0 cannot be down. It has to be up, then you can use the file system. MDT0 is, if the MDT0 cannot come back, you have a bigger problem to worry. It's not.
Any more questions for our speaker? No? Okay, let's give a round of applause.